Okay, so another type of transcendental equation is a logarithmic type of equation. Okay? These are easy to identify because they have logarithms embedded with them somewhere in the statement. I have a very basic example up here. I have 2 log base 3, 3x minus 1 plus 4 equals 8. Just like we did in the previous examples with the exponential functions, you always want to isolate the transcendental expression if you can, so that maybe you can do an inverse on it. So I think the first 2 steps should be fairly obvious. Subtract 4, divide by 2. Okay, so let's do that. So I'm going to subtract 2, or subtract 4, excuse me. So I get 2 log 3, 3x minus 1 is equal to 4, and then I'm going to divide by 2. So division by 2 yields log 3, 3x minus 1 equals 2. Right, that's easy. If you recall, remember the mantra, a logarithm is an exponent. I have a logarithm of a base 3 with an exponent of 2. Let's use the very definition of a logarithm to convert this. 3x minus 1 stays where it is. The 3 is the base, the 2 is the exponent. At this point, we can't get much easier than this. We evaluate 3 squared, we add 1, we divide by 3. So, 3 squared is 9, so I get 3x minus 1 equals 9. I add 1, I divide by 3. Right. So essentially what we're doing is we're taking something that we don't know how to work with, we're turning it into an exponential equation to which we know how to work with. Just like when we graphed it. We don't know how to graph logarithmic equations, but we know how to graph exponential. We just use that changing formula to where we convert it between the exponential and logarithmic form. Let's take a look at an example with a natural log in it. And then I'll show you guys one that's kind of tricky. Let's say I have something to the effect of 3 minus 5 ln's of x squared plus 1. And let's say that's going to be equal to something like 13. Okay. So let's go ahead and see if we can solve this out. Okay. First things first, let's isolate the natural logarithmic expression. Okay, so I'm going to subtract 3, I'm going to divide by negative 5. So if I subtract 3, negative 5 ln x squared plus 1 equals 10. I divide by negative 5, ln x squared plus 1 equals negative 2. We saw this in the previous series, that it is possible to get rid of a natural log by using the inverse. Okay? So think to yourselves, just like before, what is the inverse of the natural logarithmic function? It's the natural exponential base e. So what I'm going to do is I'm going to raise both sides to the e power. So I get e ln x squared plus 1 equals e raised to the minus 2. And this x squared plus 1 should be part of the exponent. What happens is, this goes away, and I'm left with x squared plus 1 is going to be equal to e to the minus 2. Hopefully at this point, we can easily see that there's going to be 2 steps necessary to get to the solution. We subtract 1 from both sides, so I get x squared equals e to the minus 2 minus 1. And then I take the square root of both sides. One possible answer is x equals square root of e to the minus 2 minus 1. We can't forget, whenever we solve, if we have a quadratic, we take the plus and minus of both sides. Another possible answer you might see is that they don't like negative exponents. When I say they, I mean textbook publishers, people in mathematical fields. So what they'll do is they'll take the reciprocal, just like we've done several times. X equals plus or minus the square root of 1 over e squared minus 1. Some people might even get a common denominator. Plus or minus 1 over e squared minus e squared over e squared. Since we can write 1 as e squared over e squared, this could be written as plus or minus the square root of 1 minus e squared divided by e squared. We could use a rule of radicals, break it up into two separate exponential expressions. So plus or minus square root of 1 minus e squared divided by square root of e squared. And then, unfortunately, we can't take the square root of the numerator because there's a plus or a minus sign between there. But in the denominator, we can take the square root of that. So we would get square root of 1 minus e squared divided by e. Okay? And not saying that this answer is any different than this answer, okay? But there's just algebraic manipulation going on in those. Okay? So this might be your back of the book answer. This might be an answer that I would accept from you.